All right, in Chapter 7, we are going to add on to the normal distribution, which was our z distribution, and now also do a t distribution and a chi-squared distribution. Again, if you go to the book in the End Matters section, you will see that there is a table for the t distribution. The problem with the table is that there would be so many different numbers you would have to have that they can't give you everything. So they just give you the normal confidence intervals, 80%, 90%, 95, 98, and 99. So most of the time when you do the t-test, you're going to have to either use your graphing calculator or the ALEKS calculator. But I did want to point out that there is a table in the back of the book that does give you the standard ones that they might be using a lot once you get to actually calculating problems. But for now, we're going to find the t values. And so first of all, if I am going to use my graphing calculator, again, we're going to hit the second function distribution, which is on your vars key, and then number 6 for TCDF. So that means the t distribution, and then I'm doing the CDF one. So if I grab my calculator here, we again are going to hit the blue button, which is the second button, our vars button like we did before to get the distribution menu. And once I have my distribution menu, I'm going to go down to number 6. Number 6, you can see, says TCDF. It's going to look sort of like we did when we did our Z table, our normal table. We want the lower limit, the upper limit, but we also have the degrees of freedom when we do the t distribution. So if I am finding the area to the right of 1.11, the 1.11 is going to be my lower, 1.11. My upper is going to be positive infinity. So again, to get positive infinity, we're going to hit the second button and then the comma to get the E, and then 99. So I'm going from 1.11 to positive infinity. My degrees of freedom, they'll talk about degrees of freedom, but here they're just going to tell us our degree of freedom is 20. So we're just going to put a 20 in there. And once we have our information in, we'll paste it into the TCDF, which we have there. When we enter then, we are going to round off to 3 decimal places. So we're going to use 0.140. 0.140. So if I am going to do that on the ALEKS calculator, if I grab my ALEKS calculator here, it's going to look something like this. I want the probability of t being greater than or equal to, in this case we have negative 1.91, but on here we wanted to do 1.11 on our technology activity. So you'll notice on your calculator here we just have P of t is greater than. You don't have to worry about the equal to, but I'm using the P of t is greater than. I'm going to put in the 1.11 and my degree of freedom, which is 20, and I'm going to hit equals there. And you can see we got the same answer that we got when we used our graphing calculator using the ALEKS calculator. So we're going to have 0.140. So when you do the area to the right, you're going to do your starting number to infinity on the graphing calculator. On ALEKS, you just put your number in there. Now the next one there wants us to do the area to the left of negative 1.93. When I'm doing the area to the left on my graphing calculator, again, I'm going to grab my graphing calculator. I'm going to hit the second function button, which is the blue one, and then the vars key to get my distribution menu. Number 6 to do the TCDF. Now when I'm going to the left, I'm going to start at negative infinity. Again, make sure you hit the negative button down at the bottom, not the subtraction. Texas Instruments are picky that way. So negative, second function, and the comma to get your E, 99. So my lower limit is negative infinity. Since I'm going to the left, my upper limit is the negative 1.93. Negative 1.93. My degree of freedom on this one says we want to do 10. So I'm going to put 10 into my degree of freedom. So I'm going from negative infinity to negative 1.93 with a degree of freedom of 10. Paste that into my formula. When I hit enter, I have 0.041. 0.041. On my calculator on ALEKS, because the ALEKS calculator does greater, not less, that's when I have to do 1 minus that. So I would have to do 1 minus P of t is greater than my negative 1.93 with the degree of freedom of 10. So just keep that in mind, that because this is a greater than, if I want the less than, I have to do 1 minus that. If I hit equal, you can see I got the same answer as I got on my graphing calculator. Rounding that off to 3 decimal places, I'd have 0.041 for my answer. If I want to do the area between two numbers, so I'm going to grab my graphing calculator again. My area between two numbers on my graphing calculator is a little easier than if I do it on the ALEKS calculator. Again, I'm going to do the TCDF. So I'm going to do my second function button, my VARS button to get my distribution menu, number 6 to do my TCDF. And here I'm just going to put the lower limit and the upper limit. So I want to do the area between 2.00 and 2.47. 2.47. My degree of freedom on this one says I'm going to do 15. So I have my lower limit at 2, my upper at 2.47, my degree of freedom at 15. Paste that into my formula and hit equal. Ooh, I got an extra 0 there. Let me try that again. Second function, my distribution menu, number 6. Okay, 2.47, degree of freedom of 15. That extra 0 is now gone. I don't know how I had that extra 0 in there. So to 3 decimal places, 0.019, I'd want to round that up to 0.019. So on the ALEKS calculator, if I want to do between my two numbers, I'm going to do the lower one minus the upper one. So it's backwards from what you did when you had the z-scores instead of the t-scores. Since this is a greater than, and on the z it was a less than. So when you have the greater than one, you're going to do the smaller one minus the larger one. So I'm going to clear this out. I'm going to do P of t is greater than 2.00 with my degree of freedom of 15. And then on the outside, I'm going to minus that. And then I'm going to do the P of t again. And I'm going to do my 2.47, my degree of freedom of 15. And so you can see there, I took the smaller one, which was the 2.00, minus the bigger one, which is the 2.4. That was supposed to be 47. Good thing I looked, or I would have gotten the wrong answer. And if I hit equals there, you can see I get the same answer as I got on my graphing calculator. Rounding that off to 3 decimal places, 0.01, and I have to round that up to 9. So for my t distribution, it's a greater than. With my z, it was a less than. So they're slightly different when you do them on the ALEKS calculator. On the graphing calculator, you do the same kind of thing using the proper menu, of course. So on ALEKS, they, instead of having 2 separate problems like they did with the z distribution or the z-score, they had these separate from when you had the area. They're going to combine them into one thing. So now I want to work it backwards. I know the area underneath and I want to find the corresponding t-score that goes with that. So if I want to find the percentile or the t-score that goes with that, I'm going to use inverse t, which is choice number 4 on my graphing calculator. So on my graphing calculator again, if I know the area under the curve, again, I'm going to do the second function button, which is the blue one, and then my VARS key to get my distribution menu, and I'm going to use inverse t. If you remember, with the z-score, we used inverse norm. T, we just have inverse t. So I'm going to hit number 4 there, inverse t. It's going to have me enter the area, and it's going to have me do the area that is to the right of that decimal. If you remember on our thing, we had it does the greater than. So if I am finding, or the area to the left of the t-score, I should say. If I'm finding the area to the left of my t-score, I'm just going to put that area under my curve. So if I'm finding the area to the left of 0.9671, degree of freedom I have to put in there. In this case, it's going to be 10. And I'm going to paste that into my formula. So when you do the inverse t, that first number is always going to be the area to the left. If it's the area to the right, we have to do 1 minus that value. In this case, when I enter, again, I'm going to go 3 decimal places, so I'm going to do 2.065. 2.065. Now, when I do that on my graphing calculator, I am going to use the T sub button. These ones all sort of work the same. We did the Z sub button. If I want the area to the right, I'm going to do the positive. If it's to the left, I'm going to put a negative in front of it. In this case, I wanted to do the area to the left. So I'm going to put the negative T sub. Then I can put my values in. So my area was 0.9671. Since I was doing the area to the left, I made that negative. And my degree of freedom is going to be 10. And I'm going to hit equals. And you can see I get the same answer here. If I go to 3 decimal places, I'm going to use 2.065. 2.065. So if we look at the next one on our paper, we want to find the t-score so that the area under the curve to the right is 0.8962. So the area to the right is 0.8962. So on our graphing calculator again, we are going to hit the second function button, and then we're going to hit our VARS key to get our distribution menu. And again, we're doing the inverse t, so we're doing number 4. And if I'm going to do the area to the right, I'm going to do 1 minus the 0.8962. So area to the left, you just use the area. If it's the area to the right, I'm going to use 1 minus that area. My degree of freedom on this one says I'm going to use 15. So I'm going to put 15 in there. You'll see that I have, and when I paste that into the formula, the inverse t, 1 minus the area, and then the 15. If I hit enter then, I have for my t-score negative 1.317. Negative 1.317. On my graphing calculator, since I want the area to the left, oh nope, I want the area to the right, excuse me. I want the area to the right, I'm just going to use T sub. I don't have the negative in front because I want the positive answer. I'm going to the right. Then I'm going to just put my number in there. So I'm going to use 0.8962 with a degree of freedom of 15. And I got the same answer there. Negative 1.317 if I go to 3 decimal places. Negative 1.317. So on the next page it says find 2 t-values, 1 positive and 1 negative, that are equidistant from the mean so that the areas in the 2 tails add up to 10%. That means I'm going to find 5% to the left and 5% to the right so that my total area is, or the area in the tails is 10%. That means the area between my 2 values would have been 90%. Degree of freedom 11. So again, if I'm using my graphing calculator to do the area to the left, I'm going to do my inverse t. Turn this on. So second function button, the VARS button to get my distribution menu, and number 4 to do my inverse t. If I'm doing the area to the left, I just use the value 5%, 0.05. My degree of freedom is 11. If I enter that in, my area to the left is going to be negative 1.796. 1.796. Negative 1.796. Now, if I do my area to the right, I'm going to do the inverse t again. So second function, the distribution menu, number 4 to get the inverse t. And here I would do 1 minus 0.05. You could just use 0.95 if you already subtracted it. Again, my degree of freedom is 11, and when I paste that in, you'll notice I end up with the positive answer instead of the negative answer. So 5% to the left is going to be negative 1.796. 5% to the right is a positive 1.796. Those two numbers should match up. You get the one positive and the one negative. If I am doing that on the ALEKS calculator, again, for the left, you put the negative in front of the t sub. For the right, you just leave it alone. So here, I'm going to put negative t sub 0.05. My degree of freedom is going to be 11. And if I hit equal there, you see I get the negative 1.796. I would round that off to. If I'm doing my area to the right, I'm going to do positive t sub. I'm using 5% to the right. Notice I didn't do 1 minus on the graphing calculator on ALEKS. I just used 5% to the right. My degree of freedom again was 11. If I hit equal, you can see I get the positive 1.796. So I'm going to get plus and minus 1.796. Now on the ALEKS program, they're just going to have you give the positive value of C, not the negative value of C. So they would do the positive value of C and put that in there. So if I were doing this one on the ALEKS program, I'm going to clear that out. P of t is greater than or equal to negative 1.91. Since that's the greater than, I don't worry about the equal to. I do P of t is greater than negative 1.91. My degree of freedom there is going to be 3. So I'm going to put the 3 in there. And it says that I want to go to 3 decimal places, at least 3. You can do more than that. 0.924 if I round that off to 3 decimal places. If I'm finding the one between this, so this is 90%, I would say, okay, if I take 100% minus 90%, I'd have 10%, but I'm doing each tail, so I've got to divide that by 2 and do 5%. So on here, since I just want the positive one, I'm going to do t of 5%. This time my degree of freedom is 7. And so when I hit equals there, I get 1.895 if I round that off. 1.895 for my answer. If I check my answers there, it says, okay, yep, you did it correctly. So they're going to do both of them when you get on the ALEKS program. Another kind of distribution you're going to have is called the chi-squared. It looks like you have x squared, but it's chi-squared. On your graphing calculator, again, you hit second distribution menu, which is on your VARS key, and then you're going to do number 8 to do the chi-squared CDF. So this is going to work pretty much like the t distribution did. Again, if you're going to the left, you're going to go negative infinity. If you're going to the right, you'll go to positive infinity. And so if I am going to use my graphing calculator here, I'm going to clear out what was in there. So again, we're going to do second function, hit the VARS key to get the distribution menu, and you'll notice if you go all the way down to number 8, you have the chi-squared symbol. You want the CDF one. So I'm going to hit number 8. Again, it's going to do the lower limit and the upper limit. So on this first one, it says we want to find the area to the right of chi-squared. So if I'm doing the area to the right, my lower limit is going to be the 6. My upper limit is going to be my positive infinity. So second function, the comma to get the E, 99. So I'm going from 6 to positive infinity. My degree of freedom on this one says I am going to do a degree of freedom of 4. Paste that into the chi-squared CDF. 6 to infinity with the degree of freedom of 4 to 3 decimal places give me 0.199. 0.199. On my Alex calculator, again, we have the chi-squared. Looks like x squared, but it's chi-squared and it's a greater. So when you do the Alex calculator, it is going to go to the right. So I am going to go greater than 6 with a degree of freedom of 4. And if I hit equal, you can see I got the exact same answer as I got on my calculator, which was the 0.199. Now if I want to do the area to the left, the area to the left on my graphing calculator, again, I'm going to hit my second function button and the vars key to get my distribution menu. I'm going to do number 8, which gives me my chi-squared CDF. Since I'm going to the left, I'm going to start at negative infinity. So make sure you hit the negative way down on the bottom. Second function, the comma key to get your EE, 99. So negative infinity, 2. In this case, we're going to 23 since we're doing to the left of 23. My degree of freedom is 22. Degree of freedom of 22. Paste that in there. And when I hit enter, you can see I get 0.598. 0.598. If I'm using the Alex calculator and I want to go to the left, again, since I want to go to the left and our symbol is going to the right, because it's a greater than, I have to do 1 minus. So I do 1 minus the chi-squared. I'm going greater than 6 with a degree of freedom. No, not 6. That was the other problem. Greater than 23, there we go. Chi-squared was 23 with a degree of freedom of 22. So if I'm doing to the left of 23, I'm doing 1 minus that. If I hit equal, you can see I got the same answer, 0.598. 0.598. Now, if you have the area that is the area that chi-squared is equal to, there is not a button on the graphing calculator to do that. However, on your Alex calculator, there is. Notice you have chi-squared sub something. So you use this second row when you know what the area is and you want to find what the corresponding score is, the chi-squared one. So, first of all, if I go ahead and look at this problem here, I want to find chi-squared is less than or equal to 8 for my first answer. So this is like the one I just did. Since I'm doing a less than, I have to do 1 minus. 1 minus my P of chi-squared is less than, or is greater than, because this was the less than or equal to, the 8, and a degree of freedom of 11. So if I'm going to the left or the less than, I'm doing 1 minus. If I hit equal, I'm going to have 0.287. 0.287. If I know my area, here it tells me my area is 5%. If I am going greater than, I'm going to use the positive. If I'm doing less than, I'm going to use the negative, just like I did with the t distribution. Since I'm going greater than, I'm going to use the positive. I'm going to have an area of 0.05 or 5%. My degree of freedom is 11 again. And so if I hit equal there, my corresponding chi-squared value is 19.675. Two decimal places on this one. Does it say round to at least? So this one I could have rounded off to 0.29. And this one I can have 19.68. Now you can go farther than that. I could have left that one at 3 decimal places, but it says at least 2, so I was all right. So that's how I do it on here. If I have the area, I'm going to use my chi-squared. And then the other one says find the median of chi-squared. If I'm finding the median, my area is going to be 50%, right? half of it is going to be 50%. So I am again going to use my chi-squared. Whoops, I got to clear that out of there. In here, I'm going to use 50%, so 0.5 or 0.50. 50% would be where my median is. My degree of freedom is 11. I'm going to hit equals, and so my median is going to be at 10.34. 10.34. So you can't do all of these ones on your graphing calculator. You can only do the top one on the graphing calculator. The other two you have to use the ALEKS calculator for, but just to show you how that works. Uh-oh, I missed the first one, probably my rounding. Let me try that one again, because I changed that when I did that one. So if I grab my calculator, I had 1 minus my chi-squared. That was an 8 with a degree of freedom of 11 and 0.29. Isn't that what I had in there? Oh, that one did say 3 decimal places. Notice that says at least 3, and then that one was at least 2. So that's why it didn't like my answer, because I rounded it off to 2, because I had it at 3. So 0.287. Now I have it at 3 decimal places instead of 2 decimal places. Now if I check my answer, I'm okay. So be aware of that. They don't always ask to round to the same decimal place, and obviously we need to read to round them off to the right spots. So that's how that one works. You can do the top one on your graphing calculator, but the bottom two you have to use the ALEKS calculator in order to do them. All right, the next one we're going to do is find the confidence interval for the mean. This is with our standard normal curve, so we're using the Z confidence interval. Later we'll do the T one. But the first thing we need to do is enter our data into list 1. So I've already put mine in there because it's kind of a long list. But again, if you're on your regular screen and you want to do your data in your list, you are going to do the stats. So you're going to hit the stat button, hit number 1 to edit, and then under list 1, if you need to, you can cursor up to the top and clear it out, but otherwise you're going to enter in all those numbers. I've already entered in all the numbers, and so you might want to just pause the video, take some time to get all your numbers typed in, and double check and make sure you've got them typed in right. Once you've got your number entered into list 1, just to mention, if you're using the formula on ALEKS and you need the standard deviation, in chapter 3, I believe it was, we calculated the standard deviation using the stat button again, just the plain stat button. We went to calculate and we did our 1 variable statistics. So we highlighted calc, we hit number 1 variable statistics on list 1, leaving that frequency list alone. And you can see that the standard deviation, we're doing the sample standard deviation, is 14.405. 14.405. Which is also listed in your problem. But if you need that when you are doing the ALEKS formula, you can put your list in and then do your 1 variable statistics to find out that. You'll use the sample standard deviation, not the population standard deviation. So that is there. Now, once I have my list in there and I know what my sample standard deviation is, I can do a test on there to find my interval. So again, I'm going to hit just the plain stat button, hit the word stat. Instead of the edit and the calculate, we're going to go over to the tests. And what we're going to do is a Z interval. That gives me the interval where my Z score would most likely be accurate. And so my confidence level, I'm going to do number 7 to do my Z interval. Now I use my Z when my standard deviation is known, and that's why I was pointing out where the standard deviation was. So I'm going to hit number 7. We are going to use the data that we typed in list 1. So if that's not highlighted, highlight it and hit enter so that it's blinking. Standard deviation, 14.405, which I looked at my statistics to do, or it's on the paper. But if you needed to know what that was, you could do your 1 variable statistics. My list is list 1. My frequency is 1. My confidence level said we were going to do a 90% confidence level, so 0.9. I'm going to calculate that, and when I hit calculate, my interval is going to show up at the top of the screen. So I'm rounding off to 1 decimal place to the nearest tenth. So my confidence level is between 6.8 and 15.4. 6.8 to 15.4. It also gives you the mean of 11.09 if you would need that. There again is your sample standard deviation, that 14.405, and the number of values on your list, which is a 30. So confidence interval 6.8 to 15.4. I'm going to let you go ahead and try the next one that's on the paper yourself. All right, the next one you're going to find the Z confidence interval for the mean if you have the statistics. So this is like on ALEKS where you're finding the confidence interval for the population mean using the standard normal curve. On ALEKS, they're going to have you practice using the formula, but if you want to double check it with your calculator, it's easy to double check on your calculator. So if I am going to do my confidence interval using the mean, again, on my calculator here, I am going to do my second function, or no, not my second function, my stat button. I'm going to do my stat button. I'm going to go to tests, and I'm going to do number 7 to do my Z interval. So number 7 does my Z interval, but instead of doing the data that I have in this list 1, I'm just going to enter the statistics in. So I'm going to go over to stats and I'm going to hit enter. Then I have to put in the information that I know. So my standard deviation on the one we're trying is 2. My mean X bar is 23.2. And the number of items is 50. My confidence level is 95%. So I put in my standard deviation, my X bar, and my number of values, calculating 95%, and I'm going to calculate. And when I calculate that, you can see that my interval to the nearest tenth is 22.6 to 23.8. So 22.6 to 23.8. Now, if I just look at this one that happens to be on ALEKS right now, it says the breaking strengths of cables produced by a certain manufacturer have a standard deviation of 102 pounds. A random sample of 70 newly manufactured cables have a mean breaking strength of 1,950 pounds. Based on this sample, find the 95% confidence interval for the true mean breaking strength of all the cables produced by this manufacturer. Complete the table. They're going to just have you write down what the lower limit and the upper limit is. So again, on ALEKS, they're going to have you use a formula. If you want to double check your formula, again, you are going to hit the word stats, stat. You're going to do the tests, so cursor over to tests. You're going to do the Z interval, so you're going to do number 7 to do your Z interval, and then make sure stats is highlighted. My standard deviation on this problem said my standard deviation was 102 pounds. You probably can't read that very well because I was on there, but 102. My mean, it says my mean was 1,950. My number in my sample was 70. My confidence interval was 95%. And so I can put that information in. I'm going to hit calculate. And so this says to round to at least, around your answer to 1 decimal place. And so I have 1,926.1 for my lower limit. I'm going to type that one in there. 1,926.1. My upper limit, 1,973.9. And I can go ahead and check that. So on ALEKS, practice using the formula, then double check with your calculator using the Z interval for your confidence interval using the standard normal. There's one more on your paper that is a problem right from ALEKS that I'm going to have you go ahead and give a try. All right, the next one we are using our T confidence interval. You use that T interval when you're calculating your list here. Sometimes on ALEKS they will give you the list of numbers where you have to put the list in. Sometimes it'll just give you the data like the one we did on the previous problem. So in this case, if we look on there, to do the T confidence interval, again, we're going to hit the stat button and we're going to use over to tests, and we're going to do the T interval this time. So again, I'm going to go ahead and go to my list. If I hit my stat button, number 1 for edit, I've already entered in my numbers just to save some time. You might want to just pause the video for a little bit, get all your values typed in. So if I'm going to do my T interval, again, once my list is in there, I'm going to hit the stat button. I'm going to cursor over to tests, and this time I'm going to do number 8. That is my T interval instead of my Z interval. So again, you have the choice of either doing the data that you put in your list or the stats like we did on the previous one. We're going to do data. We're going to do list 1, frequency 1, my confidence interval, it says we're going to do 95%, so 0.95, which is what I have in there. And then I'm going to have it calculate, and it says here my T interval is, this one said round off to the nearest whole number, so my T interval is going to go from 500 to 626. 500 to 626. So that is if I have my list of numbers, and sometimes on ALEKS you're going to have your list of numbers. So I have one for you to try on the bottom of the page. Go ahead and on that one, carry your computations, it says, to 3 decimal places, which you're using your calculator, you won't have to worry about but round your answer to 1 decimal place. So watch on ALEKS, sometimes they have you again round to different decimal places. This one says to round to 1 decimal places. So go ahead, type that list into your calculator and find the T interval for those values. And again, when you're doing the confidence interval for the population mean using the T distribution, sometimes they gave you the list of data like on the previous one, and sometimes they just give us the statistics, which is a little quicker because you don't have to type all of your data in there. So if we look at the one on our paper, if we're using our T interval giving our statistics here, it says find the 99% confidence interval for the population mean given that X bar is 7,041.4, S sub X is 1,610.3, and N is 7. So on my graphing calculator, again, I'm going to go back to my home screen here. I'm just going to hit the stat button. When I hit the plain stat button, gives me that menu. We want to do the tests. So this time I'm doing the T test again, the T interval. So I'm going to use number 8 for my T interval. Instead of doing data, I'm going to go over to stats. I'm going to enter on the word stats so that the cursor's blinking there. And then I'm going to put in my information. My X bar is 7,041.4. My S sub X is 1,610.3. My N value is 7. My confidence level is 99%, so 0.99. And so once I have my information in there, X bar, 7,041.4. S of X is 1,610.3, and N is 7 with a confidence level of 0.99. I'm going to have that calculated. And this one didn't tell us where to round off to. We'll just go ahead and round it off to the nearest whole number. So rounding to the nearest whole number, I have 4,785 to 9,298. So 4,785 to 9,298. On your paper, you're going to do one from ALEKS, but I'll just go ahead and do this one that's on ALEKS here since it's a little quicker than doing all the data ones. It says a researcher collected sample data for 14 women ages 18 to 24. The sample had a mean serum cholesterol level measured in milligrams per 100 of milliliters of 191.6 with a standard deviation of 9.5. Assuming the serum cholesterol level for women ages 18 to 24 are normally distributed, find the 90% confidence interval for the mean serum cholesterol level of all women in this age group, and then complete your table below. So again, I'm going to do my T interval. So I'm going to hit my stat button. I'm going to go over to tests. I am going to hit number 8 to do my T interval. And I'm doing stats. My mean value is 191.6. 191.6. 191.6. My standard deviation, 9.5. I am doing a sample data for 14 women, so N is going to be 14. I want a confidence interval of 90%, so 0.90. And then I'm going to calculate those statistics. And so my lower limit rounded to one decimal place is 187.1. My upper limit rounded to one decimal place, 196.1. And I can check my answer. Again, they're going to have you use the formula, but if you want to double check your answer, you've got the statistics, you can use your T distribution in order to do so. Another confidence interval that you're going to do is a population proportion. To do the population proportion, again, you're going to press the stat button, go to the tests, and you'll scroll all the way down to A. You'll see that it says Prop Z interval. So now A is the choice that you want to do. So it says there were 500 nursing applications in a sample, including 60 from men. Find the 95% confidence interval for the true proportion of male applicants. The 95% confidence level for P is between what values round to 3 decimal places. First of all, it wants you to find what the sample proportion is, which is called P hat, and then find the 95% confidence interval of P when X is 60 and N is 500. And so on your graphing calculator, on ALEKS, they're going to have you use the formula, but on the graphing calculator, you can check your answers. So I'm going to again hit the stat button, just the plain stat button, cursor over to tests, and then I have to scroll down to A. 9 is showing, but if I keep going, you will see A. That's my proportion interval. So I'm going to use that one. I'm going to enter on A, and I'm going to put my values in there. It says that X is my 60, because I had 60 that were men. N is my total number. 500 nursing students were surveyed, so 500. My confidence interval said that I wanted to do 95%. And so when I calculate on here, it is going to first of all tell me what P hat is equal to. P hat is 0.12, which is 12%. And then it also gives me my confidence interval, which is the 0.09152 to 0.14848. We are rounding to 3 decimal places, so 0.092 to 0.148. I'm going to write those down. P hat was 0.12. My confidence interval went from I just cleared it out of my screen, so I got to bring it back up again here. So my confidence interval went from 0.092 to 0.148. So again, I'm going to have you try one on your paper, but just to give you an example of one that we have here on the ALEKS program, it says, suppose that 237 out of a random sample of 325 letters mailed in the United States were delivered the day after they were mailed. Based on this, compute a 95% confidence interval for the proportion of all letters mailed in the United States. Then complete the table. You will figure out what Pete hat is when you do the formula, but here they just want you to put in the confidence interval. So I am again going to hit my stat button. Hit my stat button here. I'm going to go over to tests. I'm going to scroll down to A, which is my proportion Z interval. On this one, 237 out of 325. So X is 237, N is 325. My confidence interval again is 95%. If I calculate, I get 0.681 to 0.778. This says to 2 decimal places, so if I round my answers off to 2 decimal places, I would have 0.68 to 0.78. And again, they want you to practice using the formula, but you can check it on your calculator. There are ones on here for other ones like the chi-squared. You have to use the formula. So on these ones that you can do on your calculator, practice using the formula, check it with your calculator. That way when you get to the ones where you can't use your calculator, you can still figure out how to do the formulas.